Here we're going to look at solving two different systems of equations using our algebraic methods of substitution and addition, and seeing what happens when we run into some of our special cases. So here first we're given a system of equations, 5x minus 5y equals negative 15, and negative x plus y equals 3. I'm going to go ahead and use substitution on this, though it would also work out to use our addition or elimination method. So I'm going to begin by taking my second equation and adding x to both sides to rewrite this as y equals x plus 3. Since I solved my second equation, I'm going to take my expression x plus 3 and plug it back into my first equation in place of y. So this gives us 5x minus 5 times, and now in place of y, put our x plus 3 equals negative 15. So distributing, we've got 5x minus 5x minus 15 equals negative 15. So 5x minus 5x, our variable terms cancel out, and we're left with the statement negative 15 equals negative 15. So the variables are gone, and what's left this time is a true statement. Negative 15 will always be equal to negative 15. So because this statement is always true, it's telling us that we have infinitely many solutions that will make our original system true as well. So this type of system with infinitely many solutions is called a dependent system. So it has infinitely many solutions. So what's really happening graphically is if we were to graph each of these equations, they're both describing exactly the same line. That if we solve both of them for y, they're both going to be the equation y equals x plus 3. So our solutions are infinitely many solutions. What those solutions are is every single point on the line y equals x plus 3. So that line is made up of infinitely many points. Every one of those points is a solution to the system. So another way that we could actually write this solution is we could write it as an ordered pair using a variable. So we could use our variable x and say every ordered pair will be of the form x comma y. So if you pick any real number for x, the y will always be equal to x plus 3. So this is a way to write as an ordered pair that describes every single point that's on the line y equals x plus 3. So since there's infinitely many choices for x, this will give us infinitely many different ordered pairs on that line for this dependent system. Let's look at another example. So here we have 4x minus 6y equals negative 10 and 8x minus 12y equals negative 28. This one would be a little bit more challenging to do using our substitution method, just because there's not an obvious choice to solve for either x or y in either one of our equations. So instead I'm going to practice using my addition method or elimination. So this method is based on the idea of opposites in our coefficients. So you can choose to work on either your x's or your y's. If we look at our x's, I notice that the second equation has a positive 8x. I would like for my first equation to be a negative 8x. So to accomplish that, I'm going to multiply my entire first equation times negative 2. So my new first equation is going to become negative 8x plus 12y equals positive 20. I'm going to just recopy my second equation. And then I'm going to add these together. Notice what happens. Negative 8x plus 8x cancel each other out. 12y plus negative 12y also cancel each other out. So there's nothing left on the left-hand side. But 20 plus negative 28 do not cancel each other out. They leave negative 8. So we're left with the statement 0 equals negative 8, which is always false. So this is telling us that there is no xy pair that you could ever find that will make 0 equals negative 8. So there's none that will ever make that original system true. So this is what we call an inconsistent system. It has no solution. If you were to graph these two lines, what you would see are parallel lines. So parallel lines by definition have no intersection point. So there is no point in common between these two lines. So there is no xy that they share as a solution. So an inconsistent linear system happens when we have parallel lines. It gives us no solution. And when we try to solve using either substitution or elimination, we will have all of our variables cancel out and we'll be left with a false state.